This PowerPoint presentation video is on polymer dilution math. As always, I claim no ownership to any of the questions or material presented in this video, as everything is sourced off the open internet. In the following slides, I have, to the best of my knowledge, presented the correct formula and the proper answers. This is a study guide for treatment math. I'm doing this to help me learn. If it helps you too, that's great. So here we have the formula for liquid polymer off the state of Florida formula sheet. As always, I recommend, if your state gives you a formula sheet when you take the exam, I suggest you get a copy of it and get familiar so that when you take your test you can find these things. So the state of Florida liquid polymer gallons is equal to the polymer solution percent desired times gallons of solution divided by the supplied liquid polymer percent. So I also wanted to show this formula written in a different way. So the concentrated chemical in gallons is equal to the desired chemical solution percent times the gallons needed divided by the concentration of the chemical that you already have. So the top one, the liquid polymer one, is from the state of Florida specific formula sheet. The concentrated chemical is just the same formula, just using different words. So this is why I recommend that you get a copy of the formula sheet that your exam uses, because things may be worded different on different formula sheets. Alright, let's jump into the questions. A liquid polymer is supplied to a water treatment plant as a 30% solution. How many gallons of this polymer should be mixed in a tank to produce 100 gallons of a 0.5% solution? As with all word problems, I like to start off by pulling out the known and the unknowns. So what you know is that you have a 30% solution. You need to make a 0.5% solution. You want to make 100 gallons, and what you don't know is how many gallons you must mix. So again, the formula we are using for this is the liquid polymer gallons is equal to the polymer solution percent times the gallons of the solution you're going to make divided by the supplied liquid polymer percent. One thing I will mention at the beginning of this that I forgot to earlier is that your percent is as a number, not as a decimal. So just remember, when you're going through these formulas, if it asks for it as a decimal, it will tell you. If it doesn't, it just wants the percent as a number. Alright, so we're plugging in our numbers. So we have 0.5% solution desired times the 100 gallons divided by 30% of the solution that is supplied. Go ahead and do the math on the top. So 0.5% times 100 gallons, and that equals 50 gallons. The percents are going to cancel out, so 50 gallons divided by 30%, and you get an answer of 1.66 gallons, and that would round to 1.7 gallons on a lot of tests. All right, question number 2. A water treatment plant uses a liquid polymer which comes from the manufacturer as a 26% solution. The mix tank has a 250 gallon capacity. How many gallons of this polymer must be mixed to fill the tank with a 1.5% solution? So as I like to do, we start with our known and our unknowns. So what we know is that we have a 26% solution. We need to make a 1.5% solution. We're going to make 250 gallons of that 1.5% solution. And what we don't know is how many gallons of the 26% solution we need to mix in the tank. Again, the formula is the polymer solution that you desire percent times the gallons of solution you want to make, divide by the supplied liquid polymer percent. We're going to go ahead and plug our numbers into our formula. So your desired 1.5% times the 250 gallons you're going to make divided by the 26% solution that you already have. And again, we're just doing it 26%. We're not doing it as a decimal because the formula does not ask for it as a decimal. So we'll go ahead and multiply the 1.5% times 250 gallons on the top. You get 375 gallons. Again, the percents are going to cancel out. So 375 gallons divided by 26%. And the answer is 14.4 gallons. That might round to 14.5, might round to 14, just depends on when you take the exam what your A, B, C, D options are. Question number 3. A water treatment plant receives a 10% polymer solution. Calculate how much polymer should be mixed with the 3,500 gallons of water to produce a 1.5% solution. So again, we start with our known and our unknown. So what we have is a 10% polymer solution. What we need to make is a 1.5% solution. We're going to make 3,500 gallons of that. And what we don't know is how many gallons of the 10% solution we're going to have to mix. Same formula, polymer solution percent that's desired times gallons of solution divided by the supplied liquid polymer percent. So we're going to go ahead and plug our numbers into the formula. So we have the desired 1.5% solution times the 3,500 gallons divided by the 10% solution provided. So you do the math on the top, 1.5 times 3,500, you get 5,250. We're going to divide that by the 10%. Again, the percents will cancel out and leave you with gallons. And you have 525 gallons is the answer. Question number 4. A water treatment plant receives a 5% polymer solution. Calculate how much polymer should be mixed with 300 gallons of water to produce a 0.6% solution. So again, I always like to do my known and unknowns out of my word problems. So what you know is that you already have a 5% polymer solution. You need to make a 0.6% solution. You want to make 300 gallons, and you need to know how many gallons to mix. Still using the same formula. Polymer solution desired percent times the gallons of solution divided by the supplied liquid polymer percent. So we're going to go ahead and plug everything into our formula. So your desired 0.6% times the 300 gallons you want to make divided by the 5% solution that you're provided. So you do the math on the top, 0.6% times 300 gallons. Get 180 gallons. The percentages will cancel out. So 180 gallons divided by the 5%. And the answer is 36 gallons. Alright, so that was 4 questions for polymer dilution math walked through with the formula. It's pretty easy, plug and play. Hopefully this video helped you out. Like I said, this is a study guide. It's helped me learn. If it helps you too, that's great. Thanks.